All right. Now to dive into today's presentation. Today we're talking about large-scale simulation in Visum. So primarily talking about dynamic traffic assignment. The goal of today's presentation is to give you a little bit of background about, what that is and how to do it. A lot of times people don't know quite where to start. So as part of today's presentation, we're going to actually walk through in the software, setting up a simulation model from scratch. So before we start that though, we're going to go ahead and do a little bit of background information. So we're going to go through first DTA basics as well as some use cases. Then we're going to go through building the model, getting everything set up, actually running a simulation, look at some of the evaluations you can get out of the model, and then go through a Q&A. All right, so DTA basics. So why would some people use dynamic traffic assignment? As opposed to static assignment, you have the ability to make things change over time. So it's really useful for modeling things like heavily congested networks, where demand may be changing over time. Any networks where you have transient congestion, conditions change over time, such as speed limits, toll pricing. Also for doing things like roadwork and incident management, where you may have lane shuts down, rerouting, things like that. And evacuation planning is another area where we see this utilized quite a bit. So we talk about dynamic traffic assignment, PTV Visum. There's a couple different routes you can go. The most popular and what we'll be focusing on today is simulation-based assignment, or SBA. So what this is an event-based mesoscopic simulation. During the course of this simulation, all individual vehicles are being simulated. It utilizes a simplified car following and lane selection models. And then conflicts at intersections are controlled through gap acceptance and signals. So when a SBA gets executed, it goes through a pretty basic set of steps. So the first thing is a shortest path search. The network is then balanced, and then the demand is loaded onto the network, or the simulation actually takes place. So this is an iterative process. It goes through this multiple times until it reaches a termination criteria. So typically that will be either a relative gap or a number of iterations that you can set. Just to give you an idea what an overview of what actually happens during the simulation, we'll talk a little bit more about this later. So what do we mean by a simplified car following model? So as opposed to something like Visum, it's quite a bit more simple. So you don't have that second by second decision making taking place. It works on a couple of different main factors. The first is if a vehicle it will travel at the highest possible speed. So this is set in that free flow speed on the link or on the turn. And this would be the maximum speed. So typically this would be either the speed limit, or if you knew, for example, on the interstate or something like that, people typically travel a little higher than the speed limit. That's what you would code that as. Now, if a vehicle's unable to maintain maximum speed, so if there's congestion, it's going to maintain a following distance that's based on an effective vehicle length, which is the standstill distance and the length of the vehicle, and there's a reaction time. We'll talk a little bit about how you can modify those parameters later, but this is, there are some defaults in there. Here are some of those parameters that we see we need to set up: that reaction time, effective vehicle length. No need to dive too much into this already, but just to give you an idea at some of those parameters. With all these model parameters, there are default values, which tend to be a pretty good starting place, and then you can always go through and calibrate as necessary. So there's also a simplified lane selection model. So whenever a vehicle enters a link, it has to choose which lane it's going to travel in if there's multiple available links. So there's no lane changing going on in between or on a link. That selection is driven by two factors. The first is the density. So, obviously if there's two lanes, it can choose either one. You're going to go in the least congested lane, but also you're going to choose a lane that allows you to make any turns that you have. So, that path has to be respected. So if we have a vehicle here down at the bottom and it's entering the lane, traveling northbound, let's say that is on a path where it has to make a right turn, the only lane it's going to be able to choose is that right lane because it has to in order to make that turn. Same thing, if you're going to make a left turn, you would have to choose this left lane in this case. Now, if you're traveling northbound, because you don't have to be in any specific lane, because as you can see here, both of these lanes can go straight, then you're free to choose either of those lanes. There's also a parameter if you happen to have areas where have really short links, or you want that vehicle to make lane choice decision, further upstream. There is also a SBA look ahead distance for lane choice parameter on the link that can allow you to tweak that a little bit if you have specific circumstances that need to be adjusted. All right, so at intersections, conflicts are based on the control type and the geometry at the node, and it's going to use factors similar to HCM. So if you have a vehicle entering from the right here, and it's waiting to make a right turn, it's going to have to wait for a critical gap that's within the threshold. And then the other piece is follow-up gap. So if we have two vehicles making a right-hand turn and one turns, then the other one's going to have to wait for that follow-up gap. Again, this can be calibrated locally across the network. All right, those are it for like the kind of basic information about how the model works. So we'll talk a little bit about the modeling process. So a lot of this is going to be driven by what your starting point is. There's a number of different ways you can start. You could be starting, obviously from scratch, building a network. That could take quite a bit of time, as you can imagine. You may be starting from either an entire or a sub area of a regional travel demand model. In that case, you may need to add some additional details at the intersection level, for example. You may have a bunch of stuff like Vistro files, stuff like that. So your process is going to always depend a little bit based on what your starting point for that network. This is a good overview of what you need to define, and we're going to go through each of these in a little more detail. So links, turns, and connectors in the network, you have to define transportation system. At the link level, number of lanes, free flow speed, what type of control is at the intersection, what the intersection geometry is, demand and the demand time series, as well as any other time varying attributes that you want to have in your model. So at the node, here's a screenshot here. You're going to define things like lane turns. You can add pocket lanes, channelized turns, what type of controls at the intersection, as well as possibly signal timings. And this is where you can also do some local calibration of the gap acceptance if it's required. And this is another screenshot of how you define those lane turns, which we'll go through actually when we open the software too as well. All right, these are the default values for those critical gap and follow-up. So these are the values that are used by default, and then you can override locally. All right, for intersection control, you have 6 different types to choose from. The first is unknown, which is used primarily for merging behavior. There's an uncontrolled, which is similar to a yield. Two-way stop, which works as you would imagine. Always stop, the same. Roundabouts or signalized intersections. So at the link level, as we mentioned, you do need to define the free flow speed for each of those, for each link, as well as the number of lanes in the transportation systems. Then for those car following parameters, you can provide a local scaling factor. So if you need to calibrate that with individual links for queue storage, storage capacity, anything like that, you can. So one of the common things people do with DTA is obviously their demand is going to vary over time. So in order to do that, you need to set up a demand time series in Visum. And there's two different ways to do that, which I'm going to go through. So you'll have a time period with a start time and end time. In this case, the example here, we have from 7 o'clock to 9 a.m. And then we have those in 15-minute time intervals. So the first way you can do this is a time series by percentage, where you have one matrix that has all the demand for across that entire time interval. You can then assign a weight to each of those time intervals and a percentage of how much of that demand gets assigned during that time period. So that's the first way. The kind of downside to this is a really simple way to do it. The downside is it's more difficult to take into account things like if demands coming from different directions during the course of this, like this applies that scaling factor equally across the matrix. And we'll look at this in the software, but this looks like when you define that. So you have each of your time interval, 15-minute time intervals in this case. You can assign a weight to that. It will calculate that share percentage of demand that gets. Second way to do that is a demand matrix time series. So in this case, rather than having one matrix, you actually have an individual matrix for each of those time periods, which then is what is used for the assignment for each of those time periods. And in this case, rather than assigning a weight to each of those time periods, you're actually selecting the individual matrix. So depending on what kind of data you have, this is definitely a more detailed way of doing it. One thing we see a lot in DTA, a lot of these models are really operationally focused. So a lot of times we're utilizing things like turn counts, field collected data. So it's good to mention that there's a matrix estimation in Visum. So this is a process by which helps you fit that assignment to the observed counts. Visum has 3 different versions. They're called T-flow fuzzy, least squares, and there's a dynamic least squares. So basically the process here is your demand is assigned to the network. It's compared to the turn counts, and the matrix estimation modifies that matrix, and this can be done iteratively to get a little bit better fit to those observed counts. Now this would be a static. It also is available as dynamic matrix estimation. So rather than this happening once across that entire time period, it's actually calculated for each of those time periods individually. In order for you to use this, you have to use that matrix time series. You can't do the time demand time series by percentage. One of the other things we mentioned you can set up is these time varying attributes. So this is where you would set up, for example, if you had speed limits that change over time, toll pricing, things like that. That's available via the network menu and time varying attributes. All right, so at this point, that's kind of it for the background information. So we're actually going to jump over to Visum at this point and get a simulation set up. So I will open Visum. All right, so we mentioned earlier, what your starting point is. In this case, we wanted to use a little bit like manageable size network to set up at first. So what I actually am going to use today is a Vistro network. So this is a network that we typically use for signal optimization or traffic impact analysis. The good news is with that, if you have it set up with all that geometry, signal times, all that stuff comes right into Visum. So I'm going to go ahead and just drop this Vistro network into Visum, and it's going to open. So the network I'm actually using, if you are a Vistro user, if you go into the example files, there is under the signal optimization folder, there is this Austin, Texas network. So again, this is kind of a manageable size network for us to deal with today. So let me also just go ahead and load up a graphic parameter file that we can look at. Here. Just turn this off. Take just a second to load. All right, there we go. So we have this network, and just to kind of explore this network a little bit, if we click on some of these nodes here, we can go in and see a little bit more detail. So here we have detailed information about that geometry. We have the lanes, we have pocket lanes. You can come in here and look at what turns are allowed. These are lane turns. In this case, we even have information because it came over from Vistro, crosswalks, detectors, all those sorts of things. Also, because this came over from a Vistro network, we have, if I go to another intersection here, signal timing. So these are already coded. Whenever these like big simulation models come up, that's always a big question for people is how am I going to get signal timings and how am I going to enter them all? So if you have information like this from like a Vistro file, Synchro file, these you can definitely import them. You could also manually enter them, or one of the cool things, Visum has a signal timings templates function. So if you, especially large scale models, a lot of times you won't have that detailed data, but you can kind of make some reasonable assumptions. You know, typically within a particular jurisdiction, they're using this, you know, somewhere in the neighborhood, you know, cycle lengths, things like that. So you can kind of quickly apply these to those networks. Now, because this is a Vistro file, the one thing we don't have, as opposed to if we were starting from a travel demand model, there are no zones in this model right now. So we're going to create some real quick. For the purposes of what we're doing today, we're just going to create zones rather at all these exterior nodes in the network. And that's where the traffic's going to enter. So in order to do that, there's kind of an easy way to do that. First, we're going to filter out all the nodes that aren't the exterior nodes. And the way I'm going to do that is just apply a filter. Number of legs is equal to 1. And that's going to select only these nodes that are on the exterior of the network. And then we can go to zones and create. Select active nodes only. And you can modify any of these items like the types of the generated nodes. And we're just going to enter a small connector length here. What that's going to do is automatically create all those zones for us. Again, you could also, if this was a Vistro network and there was a travel demand model also, you could always import that zone structure as well and add connectors. One thing you may want to be careful with if you're adding connectors, you wouldn't want any connectors going to any of these like heavily utilized, you know, signalized intersections, because it's just going to dump traffic into those intersections. So you always want to, you know, kind of at these driveways or exterior points of the network. So just be a little like, you know, put some thought into where you're adding those connectors. All right, so we have this network. It's now we have all the basic stuff we need. Anytime you import these kind of networks and stuff, one of the first things I usually do is I want to know if this is like a routable network. Is it set up? Are all the turns set up? Things like that. So probably the fastest way to do that is just take a look at graphics, just do a shortest path search real quick. And we'll select just for node and distance. If I select, and it's going, yeah, so this is the routable network. It's coming up with the reasonable shortest path here. The other way that we can do this is if I open the procedure sequence, I can just generate a skim based on the distance. Now, whenever you import stuff from Vistro, some of these procedure sequence items are going to carry over. So I'm just going to get rid of those because we're not utilizing them at all at this point. And I'm going to create a distance skim here. Calculate skim matrix for the car demand segment. And we want to do direct distance and open it when we're done. So if I run this, it's going to pop out the skim. In the case of this network, just because of its size and the way it's laid out, we have quite a few of these really high values, which is basically there's no route from those zones. Again, that's something you could address if you're doing something in more detail, but we're not going to worry about it too much for now. In this case, I already have some demand in a matrix saved, so I'm just going to go ahead and load that now so we can get ready to run it. So let's go to matrix, and again, you have a couple of things in here that are kind of carryover from Vistro. We're not going to use them in this case, so I'm just going to get rid of them. And then we're going to add an external matrix to the network model. I'm going to call this just car. And go over here and load this. All right, so we've loaded that. At this point, before I go to actually run a simulation, usually the first thing I'm going to do is take a look and see if we can run a regular static assignment. So in this case, I'm going to do that. Just create static assignment car. And before we can actually run this, there's a couple things we have to set up. First of all, we're just going to make sure our transportation systems are defined properly. So we have car here, which is what we want. If I edit that, this is how you set up those global car following model parameters. So reaction time, effective vehicle length, and this maximum wait time. This comes into effect if at any point a vehicle gets stuck at a junction and it can't go. After a certain amount of time, it'll allow that to go to keep a vehicle from being stuck there through the duration of the simulation. So okay. And now we're going to set up that demand time series that we talked about. So first thing we're doing is set up the demand segment. So we have the car segment here. I'm going to select that matrix in this case. Okay, the one that we imported. Now we're going to create a time series. So there's one in here by default. The first one we're going to create is for a time series by percentage. So we're just going to create. And I'm just going to call this, like, pretend this is a morning peak. So AM peak, and it's a time series by percentage. We're going to edit it. And this is where we can create those time intervals. So I'm going to create multiple here. And it's going to ask you for a start time in day, an end time in day, and the duration, which is how long are those intervals. So I want to go from, we'll just say day 1 from 6:30 to, still want to be in day 1, 9:30. And we want 15-minute increments. And then it's automatically going to create those. Because this is that time series by percentage, we may want to add some, make the demand change over time. So we're going to weight this a little bit differently here, just for the sake of this. Enter some quick values, and it automatically calculates that share percentage, and it's always going to add up to 100%. So we're going to create, that's there. And then we're just going to make sure we are using that. So select AM peak here. Should be good. And hopefully, if I didn't forget anything, now we should be able to run that static assignment. It does, that looks good. And if I add in my graphics parameters, it should load up here for me. So if we want to see the flows, links, bars. And so our static assignment ran fine. So that's usually the first step. I like just make sure an assignment runs before we get into the actual simulation itself. So now we're going to turn this into an actual simulation. So we're going to go back to the procedure sequence, and rather than choosing an equilibrium assignment, we're going to swap this over to simulation-based assignment. Most of this other stuff is going to stay the same, but I'll double click here. It's going to bring up the parameter windows for simulation-based assignment. So there's quite a few parameters in here. Some of the things you can change are quite specific. I would definitely recommend, if you're going to use this, to take a look at the manual. It's got pretty good explanations of what all these things are. Basic things we talked about though, the termination criteria, so the number of iterations or the relative gap. So this is what's going to, stop that simulation from running once you get to that point. Now the assignment time period. This is where you need to define the period of time that this is going to assign the demand to the network. We want this to match up to what we put in the demand time series. So I'm going to put 6:30 to 9:30. And then there's a post-assignment time period. What this is for is it allows any vehicles that are in the network once the assignment period ends to have time to get out of the network. By default, this is 1 hour. For this purposes, that should be fine. And then it kind of explains to you here in pretty straightforward terms. This is going to go from 6:30 a.m. Oh, what did I do here? There we go. From 6:30 to 10:30. Because we have 6:30, 9:30 plus the hour period, but once 9:30 hits, no additional demand will be added to the network. There's just time intervals for balancing here. We're gonna not worry about that today. The last thing is you need to create analysis time intervals for the simulation period. So, static assignment, like all those results are lumped into one time period. Because this is dynamic, we want it to match up with the demand so we can collect, this is basically a container to collect results. So you can easily automatically create matching ones here within this dialog. If you hit it, we want that 15 minutes to match in this case, and it's going to generate those analysis time intervals. Hit okay. And then there's actually one more thing we want to set up here. Volume balancing, we won't get into that today. There's a couple different methods that are available. Base volume. You do have the ability to add a base volume into the network to the links. So basically you can have a volume that's not involved with the demand structure that we set up at all. Might use this if you have, high volume of, public transit vehicles or something. You could put that in there just to kind of take up that space. But we're not going to do that today. And the last part is the cool part, which is visualization. So we're going to make sure to record the vehicle trajectories for visualization. So if you're a Visum user, use Visum before, unlike Visum, we're going to run the simulation, and then the video that we're going to see is going to be like a post-process. So we have to record that. It gets recorded locally in a pretty efficient binary file. So just select that to make sure that that it collects that data. And I think we should be ready to go ahead and run this at this point. Let's try it. And we have a few errors, which a couple of these errors, this is probably going to happen the first time you go to run any of these networks, because there are usually going to be some small items you may have missed in setting up that network. So let's take a look and see. On these errors, you have a couple things about lane turns not existing for open turns. So if we go to our junction editor and look at look there, and now if I select this, it's going to take me to the place where that error is happening. And because I know this was going to happen, what you will find is that geometry, there we go. And if I select lane turns, is that in the network, there is a turn that goes from this left-hand lane across. But if I look at the actual lane turn itself, that's not allowed. So there's two ways you could handle this. If you want it to be open, I can click here, it'll open that up and that'll clear the error message. There may be some cases where you might not want that to happen. In that case, I could just delete that. Go to the turn and actually find that turn here. and remove it from the TSYS set, and that would shut that turn down. But we'll leave it on for now. The second one is back to geometry. Is this one here, and in this case, again, there's a turn here that is not allowed as a lane turn. So I'll just click that, and that should open that up and allow that to run. So we'll try to run it again, and we'll get a couple more errors. So these errors that come up these are links where we haven't defined a free flow speed. For whatever reason, I didn't dig into the vStro network on this, but some of the speed limits basically aren't flowing through. So same thing here. If we go back to junction editor and select links, and I click on the error, I can easily go through and see that the speed limit is defined as 0. All the others are 30. So I'm just going to clear these real quick and go ahead and add these. Same thing. So this is the stuff you'll typically have to do. No matter how well you prepare, usually there's going to be something you missed. Back to procedure sequence, and I missed one. If I hit run, now it's going to start to run. So you see this runs pretty fast. This isn't a big network, obviously, but it's clicking through these iterations. And you can see the relative gap and all this information here, and there's some ways you can view that afterwards. While that's running, this just takes a minute, but I'll go ahead and show you one thing, that those time intervals tend to be a little confusing to people. So I'd like to lay out how those relate. So the first thing we set up with that time series by percentage in this case was a demand time series. So that was from, this time's a little different, but 7 to 9 in this case. You then have set up the SBA simulation time, which consists of the assignment time period, which in this case matches, plus that post-assignment period or cooldown period when no demand's being fed into the network. And then we created automatically those analysis time periods that are going to allow us to collect results for those time periods. So this is a good kind of way of visualizing how all those different time periods. One common error that you'll see when you try to run it is it'll come up and say that there's no demand for the simulation time period. And that's usually because this demand time series and assignment time period don't match up. So you just have to make sure that these are at least consistent with each other. So if we go back, it's just finishing up now. This is just some sample demand. So, all right, so if we go back to our network editor here, we still see the same flows that we saw before in the static assignment. Now one thing that did appear, because we're now in this dynamic assignment, is this time stamp up here. So starting at 6:30 when we started, and you can click through. And in this case, it doesn't look like anything's changing. That's because this is still viewing those original assignment results. In order to change that to dynamic, we're gonna edit the link graphic parameters, link bars. So instead of this volume for the entire assignment, we're gonna click, and it's going to come up. We chose the analysis period initially, which is the entire analysis period, but you can click current time interval, and this will allow you to view results for each of those individual 15-minute increments that we defined. So okay, okay. And now, as I step through, it's not going to be, so this is sample data, so it's not going to be a giant difference, but you'll actually be able to see these link bars change over time as we step through. You may also want to explore at the link level some of these things. So if we hover over a link and right click, we can look at charts. So we choose column charts, and this comes up with link volume, which we see the time intervals down here, and that does change over time, but there's a lot more stuff we can look at. So we can go settings. I'm going to delete this public transit here. And let's create another chart, which would be link speed per time interval. Hit create. We'll change the color to something different. Whenever you're talking about any of those, like a lot of those attributes that are collected for SBA, those results, if you get into like this select attribute dialog box, you can search. If you hit SBA, that's gonna, bring you, and you see you have all the stuff like, density, queue length, detail. So in this case, we're gonna look at detail for the speed of cars. Hit OK, and this one is not going to be too exciting because I think I chose a link that we don't have a ton of congestion on. But if I were to go and choose another link, probably. That's not too bad either. There you see a little bit different. So you see how that speed changes over time. So you can dive down at the link level, node level, all those things. Also, if you go back to our junction editor, you can always choose turn volumes, and that'll give you turn volumes. All right. But what most people want to see is that visualization. So to view that, we go to View and SBA Visualization. And that's going to load up our network in this other window here. And you can see that we have this kind of basic version of the network here. If we zoom in, we see the links. Also, for any of these signalized intersections, you see these red and green colors that represent, what signal heads are active. And if we press play down here, now, this is running at 1x speed, but you should start to see demand load into the network very slowly here. We can crank that speed up to as high as 16 times, and you can see vehicles start to enter the network. So in the course of that time, we were able to get this up and running. Now down here at the bottom, you'll see these tick marks along this kind of next to the play bar here. Those are defined as analysis time intervals. So if you want to jump ahead, you can always click jump ahead. You can zoom in if you want to see, more detail. Then I should have some different visualizations loaded up here as well. Where were we? Drop this on. We can just define them here. So here you can define SBA trajectories. You can define whether or not you want to draw those links, connectors, the signal heads. You can also change how those vehicles are displayed. There's only a couple things you can do. In this case, a smooth speed, the transportation system. So maybe if you had different demand segments and you want to visualize, all of the freight vehicles is red and all the, regular passenger vehicles is green, you can do that. You can also go in here and, load the background maps up behind you, pan and tilt, all those sorts of things. You'll notice up here, this is kind of like sample demand I loaded. Network is pretty congested up here, so you see the effects of spillback. So that's kind of the basic version here. Now, one of the other things I'm going to show you is I do have another network loaded up already that has some little bit different information in it. So let me just pop over to that. So if you remember in that first network we set up, we only had the one matrix that represented, the demand, the entire demand of the simulation. In this case, we loaded one for each time series. So you have all these different time series. If we see what that looked like, if we go to demand data, and look at that time series, if you remember what it looked like when we created it before, rather than assigning that weight and it calculating the percentages, we actually individually select the matrix for each of those elements. All right, and that should be pretty much it for within Visum. There are a couple other quick things I do want to point out as well. Just go back here. Obviously, the point of this presentation today was just to kind of give you a good idea of what's the bare minimum requirements are to get the simulation up and running so you can start trying it for yourself. There are some really great places to get additional information, a lot more detailed data. The first is obviously going to be the Visum manual that comes with your installation. It's going to talk about a lot of those different parameters that we didn't really cover today. One also thing to show you as well, which should work. If I go back into those simulation parameters, something a lot of people don't know is that Visum has pretty good context sensitive help. So if you hit F1 when you're in any of these, it should bring up, detailed help about all those parameters and has all those details. Also, any of these little information buttons you can hover over, you can take a look. Also included with your installation of Visum, there's an example for SBA. In that directory where the example is kept, there's also a best practices guide. It's kind of got like a little bit more practical information as well as like Q&A, it's our FAQ type information there. There's some other, publications out there. There's a ton of publications about DTA. One in particular that talks about SBA is a multi-resolution modeling for traffic analysis guidebook. So that was recently published. So it's another great place for information about DTA in general. And with that, I am going to go ahead and start the Q&A portion. So if you have any questions, please feel free to ask them.
All right, Adam, thanks for the presentation. Can you hear me?
Yep.
Okay, so there are a couple of questions that was up, and I think the first one was like, very straightforward and short question. So, which I already answered, but I think, it's going to be worthwhile to mention that again, which is like, we asked like whether we're showing Visum software or not. I can,
yes.
I understand it is Visum. I didn't expect to see too many moving vehicles in the Visum software itself, but now there is actual simulation component in there. And the second question could go to maybe Chayton, if I think you were there, right? So, which is what is the difference between just the regular DTA and simulation-based DTA?
Yeah, sure. So DTA is a more generic term for just dynamic traffic assignment. And the reason we specify simulation-based DTA is because dynamic traffic assignment can have different methods of loading. So certain analytical methods do not simulate the network, but use analytical models to load the network. But in this case, since we actually run a simulation to load the network, we name it simulation-based DTA. So that's essentially the difference. There isn't really a difference, but it's more simulation-based DTA means a more specific method of loading, which is simulation of vehicles over the network rather than using, let's say, analytical models and other macro methods for loading the network.
Okay, thank you. And another question, this is more like, I don't know, like, you can answer that, Adam, as well, which is like, is there an additional module required to run this DTA in Visum?
Yes, there is. So depending on what like license instructions you're under, it could be either its own module like SBA, or we call it now like the road package, which includes some other elements that you may need as well for doing this. But yes, this is a separate module. It's not included with like the base version of Visum.
Okay, sounds good. The next question. Oh, more and more questions coming in. Cool. Do the signals in here coded as a pre-timed or RBCs work as well?
It can be an RBC, but I should point out that there's a couple things that it doesn't take into account. So you can't, it's like a fixed time RPC. You can't have actuated signals You're not going to have things like preemption, TSP, any of those like really detailed signal timings, but the signal timings that were in that model we just looked at came directly from, the RBC signal within, that was built within Vistro. And you do have, the option to edit that within Visum as well. You could also use like a stage-based signal timing as well.
Okay, the next question is, can you please show how to run calibration and load the model with the existing turn counts and link counts? So I think, Adam, if you can show that calibration component and then where to add those turn counts and link counts probably as a, additional attribute.
Yeah, absolutely. That's something I did not cover. So again, like one of the benefits of using like that Vistro network is you typically, if you don't know, Vistro is used for like HCM analysis, signal timings, but has a base volume input that allows you to enter hourly turn counts. So if we go to nodes and just choose this one, and we go to, in this case, they're added on the turns, but you can also do it for links as well if you wanted. So if I do that and add attribute selection. So if you're using a Vistro network, those those counts flow through as this Vistro base volume input. So hit that, hit OK. What happened? Why did that not? Oh, there you are. So you'll see these turn counts. In this particular network as well, you can create a user-defined attribute that lines up with those time periods, which I did in this network and did not cover. So if we go to network, user-defined attributes. In this case, I created one called counts, which lines up with those analysis time intervals, and use that to store like 15-minute turn counts. So if we go to look at those turns list, I can bring those up. Let me just get rid of this stuff. And so I have those turns counts loaded in here, and you can see that for each of those turns, there's a time period attached, so you can add that. As far as the calibration parameters, if in the procedures sequence you set up this assignment analysis, it'll collect that information. If I look at that, and so in this case for turns, we can compare those volumes for the current iteration versus the count for the current time period. So that will compare those. And then if you go to, once you run the assignment, if you go to calculate assignment analysis and chart, perhaps I cleared it out. And that will show you that, we'll show you those details. What did I do? Maybe because I changed something after I ran it, but that will actually bring up one of the, like a chart and give you some analysis. Another handy place to look for general information about what happened during the assignment is under lists, statistics, and there's a simulation-based dynamic assignment quality data. And that'll give you a wealth of information about that as well.
Okay. So while we're on that topic, there was one more follow-up to that, asked by a different person, but similar topic, which is, so we've mentioned about calibrating the model based on the turn counts and link counts, basically counts. How about the other one, like speed or some other data that's going to be available? Can those be used also for calibration?
Yeah, you could definitely use that for calibration and change some of those parameters. Whether it be free flow speed. You can also, one of the results you get out of here at the node is like queue length. So you can look at all those types of things. And then, calibrate any of that behavior locally at the links. I kind of mentioned in the presentation that you've got all these global parameters for car following, gap acceptance, things like that. But in each individual element, then you can always override that if you're seeing behavior that doesn't make sense to what's observed in the field.
Yeah, We have global parameters provided for car following and gap acceptance, but then those can be overridden on specific links and such if you have the data for it.
Okay, so now I think we can change the gear a little bit, and this is more, I mean, this may end up being more of a question for you, Chetan, which is how is Visum interfaced with the several third-party activity-based models?
Interfacing with...
I changed gear too much, I guess.
Yeah, the interfacing with most third-party activity-based models with Visum is using a Python bridge. So essentially, we have a Python integration in Visum, which allows Visum to talk to third-party interfaces with any of the typical ABMs that you might have, like CTRAMP or DaySim or ActivitySim. And in each case, we typically do a matrix exchange of matrix data exchange with passing of the scheme, the level of service data, and some other data for the ABM, and firing the ABM off using some of the OS system modules in Python. So that's essentially the interfacing through Python bridge.
Okay, so I think, Adam, we can take this as a last question, and then we can just try to wrap up the session if that works for you. The last question that we can pick up here, and of course, the rest of the other questions are going to try to be answered via email. So the last question that we're going to pick up during the session is, since signal timing comes from the Vistro file, if the Vistro file has various timing plans based on the time of day, does that get inserted into Visum as well?
Yes, it should. So if we go back to this original network and pick out one of these intersections and look at the signal timings, you should have the various patterns available here. And then you can always load up, jump in here and edit any of those signal timings as